This is probably the machine you think about when you think about duplicating your house keys. Or you may even think of this machine, which is a whole lot more advanced than the original key cutter. But in an age of new technology, shouldn't there be a way to create your own house keys at your home? That's where a 3D printer comes in. You see, a lot of people think of 3D printers as only being useful for printing tiny trinkets and toys that you'll probably never use and lose around the house. However, there have been countless times when I've been able to use 3D printing to save me a ton of time and money. For instance, one time I 3D printed center caps for my friend's Jeep wheels because a tire shop messed up the original ones. So instead of spending tons of time trying to find replicas and spending hundreds of dollars on them because they're fairly rare, my friend simply took a few measurements and sent over a model that he created, which I printed out in carbon fiber nylon. Then we installed these onto the Jeep. And in my opinion and his, we think that this made the wheels look a whole lot better and the car look more complete in general. But in what other scenarios would a 3D printer be actually useful for something practical? The other day I was scrolling on a website where you can find models to 3D print called Maker World. And on this website, I stumbled upon a post that caught my attention. The post read, "Duplicate your own house keys." On the Maker World website, they have a feature which allows you to customize certain models through a program called OpenSCAD. For example, you would be able to customize something like a keychain to have a certain person's name on it, or tons of other different models, which are all found on the Maker World website. The post that I came across that indicated that you were able to duplicate your own house keys using your 3D printer is one of the models that uses this OpenSCAD feature. But I wanted to try it out and see if it actually works. The way a standard house key works is by having various ridges along the actual key itself that set in place a set of 5 different pins, and when pushed up to the correct height, they unlock the lock and allow it to spin freely. In order to replicate this with 3D printing, we will need to match the ridges along the key that we have in order to set all of the pins to the correct height and unlock the lock. But before we do that, let's go over why this will be practical and save you and potentially big companies a lot of money. Instead of having to get in your car, spend gas money, spend a good amount of time, and around $5 or $6 to get your own key made at a hardware store or a locksmith, if you're able to 3D print your own keys at your home, it can take a matter of minutes, and it'll barely cost you anything because filament is fairly cheap. We'll go over how much it costs to make each key later in this video. When a standard house key is made at the locksmith or hardware store, they start with a metal key blank and then use the machine to shave away parts of the blank until the keys match. Then you'll have a perfect duplicate of your actual key. Newer machines are a lot easier where you stick the key in, it'll take a picture of the key, tell you which key you need, and then cut it for you. But you're actually still losing material because you're cutting away parts of the key, which means you're also losing a bit of money every time you cut a key. Because all the metal shavings aren't recycled, they're actually just thrown into the garbage can. If companies were to capitalize off of 3D printing house keys, they would have very little waste when they actually make the keys, because instead of taking material away where you don't want it, you're just adding material where you do want it. This means you're only using the material that you need, which saves you materials, which means saves you money. Okay, let's get back to actually trying to print this and seeing if it works. In order to replicate the exact cutout of the key, we are going to need to know a way to decode it. And the way we're going to do this is printing a key decoder. You're able to buy these online for fairly cheap, however, 3D printing it will make it even cheaper and I won't have to go to the store or wait for shipping. Only a few grams of filament later and we have our key decoder, so let's decode the key. In order to decode the key, we need to slide each of the cuts into the decoder and it'll tell us a number that we need to input into the software. After doing this on all 5 of the cuts, we can generate a model and we can test it out by printing it on the printer. To start, I'm going to use Bamboo Lab PLA because I just want to check to make sure that the print actually works before I use a more expensive material. While PLA is cheap and great for a lot of use cases, I don't think we'll be able to use this for the actual final key design because it wears super easily and is super flexible, which is not the properties we want to have in our key. Therefore, we're going to have to use a stronger material called PETG, and we're going to test it out with that to see if it'll work because it's a bit more durable. I actually 3D printed the wrong decoder when I was trying to print this for this video, so the initial version of the key did not match up with the actual key. Instead of doing what I should have done and reprinted the decoder, I actually just changed the values until I got it right, which was on my third iteration, and I printed it in Bamboo Lab PLA. This video is not sponsored by Bamboo Lab, but they have sent me some printers and a ton of filament, and I would highly recommend their machines and their filament, which you can use my affiliate link down below if you want to support the channel, because in my opinion they are truly the best machine, and I've tried so many different 3D printers over my time. As I expected by the properties of PLA I explained before, the initial print was actually super bendy, so it wasn't able to turn and unlock the lock. But a good sign is that it actually matched up perfectly to our original key. And it also slid all the way into the cylinder, which is another great sign. So now that we have a matching key to our original, let's try and print this in a stronger material, aka PETG, to see if we can actually get a working 3D printed house key. So I loaded up some Bamboo Lab PETG and sent the model off that we had created to my Bamboo Lab X1 Carbon. When the model was 3D printed in PLA, it only cost me a few cents to make each key. And this is because each spool of PLA costs $20 to $25, or even less if you buy them in bulk, and each of the keys used only a few grams of filament, so when you calculate it all out, it only comes out to a few cents worth of filament, and the keys only took around 10 to 15 minutes to print each. But that's including the time it took for the printer to calibrate itself, so the actual printing time of the key is a lot less. Which means it takes around the same amount of time for you to cut a key as it does for you to 3D print a key. Which means this may be a possibility for implementing this into stores around the world, which would implement the benefits I was talking about earlier. But let's see if we're able to actually use the PETG printed key to unlock our lock. While PETG is generally a few dollars more expensive than PLA, the total cost of the key actually still only costs 3 cents to make, as opposed to the $5 or $6 you would be spending at the actual stores. So after only 10 minutes of printing the PETG key, we were able to take it off the build plate and test it out. And finally we have some success, because the key is a lot stronger now and we're able to unlock the lock. It still does have a bit of flex to it, so to increase the strength even more, I increased the wall loops to 10 as opposed to 2 so that it is completely solid. And I reprinted this and now it is even stronger than before. This probably isn't very practical if you're trying to use this key every day, but it's good to have this as an accidental spare. In case you ever lose your actual keys and you have nothing else to use, you can use this once or twice. Or if you decided to print it in a stronger material like carbon fiber nylon, or a super industrial material like PEEK, then this key might be suitable for everyday use. The designer of this OpenSCAD project is Ritz Prince 3D. So go check him out and show him some support on MakerWorld. Thanks for watching, and let me know if you would ever use a 3D printed key in your house lock.